Is this thing on? Looks on. Hello class, it's Mr. Lewis with your Friday lesson. This is for my Earth Science class. We'll be covering section 1 of chapter 3. I'm going to try to make this lesson quick. I know it's a Friday. Everybody wants to, do their own thing. But we do go to school on Fridays virtually. So here we go. So we're going to be covering latitude and longitude lines. If you'll notice, I've got my trusty 8-ball here, and it is covered in masking tape. So, to begin the lesson, why is it important that we know latitude and longitude? So latitude and longitude allows us to pinpoint a certain place on the globe and know exactly where we are. Okay? So, for our globe, I'm using my 8-ball. We're going to pretend that the 8 on top is the North Pole. So here we go. Okay, so here we go. So you have two lines that actually separate the globe. You've got the equator that some might say runs horizontal, right? Then you've got your prime meridian, some would say runs vertical. So the equator goes all the way around, right? Goes all the way around the Earth. The prime meridian does not, however. So the prime meridian starts at the North Pole, goes down through a little place called England, goes off the coast of Africa, and then stops in the South Pole. Okay? And it's very important that you know that, because that's one of the reasons why whenever you measure around, it goes 180 degrees in longitude lines one way and 180 degrees the other way. Right? So if you were to go this way 10 degrees from the prime meridian, you would be 10 degrees west. If you go the other way, you would be 10 degrees east. Alright? So that's how that works. If you were to go almost all the way around back to here, you'd be 175 degrees east. If you went all the way around to back here, you'd be 175 degrees west. Now, we also use the equator. So the equator uses horizontal lines, but they only go up to 90 degrees instead of 180. So they go 90 degrees north, 90 degrees south. So each one of it might be 10, it might be 20, it might be 30. So just as you go up, it goes 10, 20, 30, 40, 50, 60, 70, 80, 90, till you get to the top. Same thing, 10, 20, 30, 40, 60, 70, 80, 90, till you get to the bottom. So Washington, D.C., in our book, if you look on page 58, says that it is 38 degrees north and 77 degrees west. Now, if we were to just take a wild guess with our magic 8-ball here from where we're at, if we went 38 degrees north, so which direction would we be? North would be going off the equator, right? So that's a latitude measurement. So 38 degrees north. Let's say that's about 38 degrees. And then we're going to go 77 degrees west. Well, that would put us somewhere about right in here from our prime meridian, right? Because we went west of the prime meridian. So that'd put us somewhere right here. So where my finger is at, probably, roughly, would be about where Washington, D.C. would be on our map. Now, if you look on our pages, they'll go a little bit more in depth on page 58 and page 57 about longitude and latitude. But right now I'm just trying to give you a rough overview. Like I said, we're going to do this in class too. So, to recap, Earth, latitude lines, Earth, longitude lines, where would 0 degrees north and 0 degrees east or west be? 0, 0, where would that be? Right there. Right there. Where the equator and the prime meridian meet. And that's, in a nutshell, your longitude and latitude. Now, I said we were going to go over magnetic north and south, right? So, contrary to popular belief, once again, if this were our globe, the north and south poles are actually not magnetic, north and south. If you've ever used a compass and you thought you were going north, unless you were in Arkansas, you were wrong. And I say Arkansas because I believe the state of Arkansas is the only state for us that is lined up perfectly with magnetic north if you're in the state. I would have to look at it. We can talk about that in class. So, here's the reason why. It's because magnetic north is actually offset, right? So if we were to stick this pencil through our magic 8-ball to actually if we give our rotation of axis, it would be north and south pole, right? It'd be straight up and down. Can't see my finger. So it'd be like that, right? Straight up and down. More kind of tilted, but it would be through the north and south pole. That is our rotation of axis, meaning that is where we spin as we go through space. That is how we spin. But our magnetic north is actually offset a little bit. So that is why if you ever use a compass, chances are you're actually going to have a set of degrees that you need to add or subtract to get the exact location. But basically what you guys need to know is that our magnetic poles are different than our north and south. That's why they call them, you have what's called magnetic north, and then you have true north, and the same thing with south, magnetic south and true south. So that is why you have those, is because our magnetic poles are actually different than our axis poles. And like I said, I'm going to re-explain all this in class where I can actually have questions, answers, and do all that stuff. But there's going to be a few questions that you need to answer in your Google Classroom about this lesson. Jump on there, get that knocked out. It's not hard. I'm going to keep it easy, keep it simple. And see you guys on Tuesday. Yeah, because we're out of school on Monday. See you guys on Tuesday.